Hi everybody, Captain Al speaking with your training tips designed to help make you a better, more knowledgeable flight simmer, pilot, or aviation enthusiast. Let's strap in and stow the HUD and see what is on the horizon for today. Our briefing today will cover the Electronic Flight Instrument System, or EFIS system. We'll be looking at the PFD Primary Flight Display, and specifically we're zeroing in on the Attitude Display of the PFD. So how is attitude generated in a jet aircraft? Well, typically you have an inertial reference system that can consist of inertial reference units or an ADIRU. The ADIRUs and air data inertial reference units, air data computers, and IRU units all contained in one housing. Some of the more recent airplanes have ADIRUs. Some of the older airplanes, like the 747-400, had separate ADCs, air data computers, and separate IRUs, or inertial reference units. How is attitude displayed? Well, in the old airplanes, it was displayed by round dials, or what we like to refer to as steam gauges. In the newer airplanes, it's displayed on glass. It is the centerpiece of the primary flight display, or PFD, because, again, it tells us information for pitch, information for roll, and when we're instrument flying, that's our main focus, would be the attitude portion of the PFD. On the attitude display, you have blue representing blue sky, brown representing brown earth, and a white line representing the horizon line. The airplane symbol represents the attitude of the aircraft. At the top of the display, you have a bank scale along with a bank indicator, along with a slip skid indicator. The pitch increments on the PFD are in 2.5 degree increments. The labeling starts at 10 degrees, so you can see in this case the airplane symbol is on the horizon line. The first pitch increment up is 2.5 degrees. The one the arrow is pointing to is 5 degrees. Above that would be 7.5 degrees. And then, of course, the 10 is labeled. We have pitch up and pitch down increments represented. The bank increments are normally, they start at 0 degrees, and left or right they go to 10, 20, 30, 45, and 60 degrees of bank. The bank pointer is represented by a triangle at the top of the display, and when the bank pointer is lined up with the bank indicator, you're not rolling left or you're not rolling right. Your wings are completely level. Underneath that, there is a slip skid indicator that's represented by the rectangle, the small rectangle. Sometimes we refer to this whole combination as the sailboat, because it looks like a sailboat. And normally, if you roll into a bank, the bank pointer itself is going to point in the direction towards wings level. So if we went into a right turn, the bank pointer would be to the left, indicating to roll left to roll out of the right turn. If the slip skid indicator, which is normally centered, gets out one way or the other to the underneath it moves, and if it reaches full displacement, it will turn a solid white color. This could indicate a slip, or it could indicate a skid. Of course, this is the same as a ball in a small airplane. Typically, we like to keep the ball centered, and in a jet aircraft, it's represented by the rectangular symbol. If we bank more than 35 degrees, the bank pointer will turn amber. And if we happen to get greater than 35 degrees and we have full displacement of the slip skin indicator, the slip skin indicator again would fill in solid, but it would also be amber because the bank angle is greater than 35 degrees. On the attitude display, anytime the flaps are out of up or you have low speed with no flaps that are extended, you'll get the pitch limit indicator. The pitch limit indicator indicates where you'll encounter stick shaker. If you put the airplane symbol right under the pitch limit indicator, it would be 1 degree below stick shaker. This typically is used in wind shear recoveries if needed. That's the maximum performance you could get out of the airplane if you had max thrust and you brought the airplane right under the PLI. That's the best you could do at that given time during a wind shear situation. So that is referenced in the event wind shear is encountered. It will appear again anytime the flaps are out of up. Let's take a look at the virtual simulator. And we're taking a look at the attitude portion of the PFD. And you can see here we're at 280 knots, we're at 10,000 feet. Autopilot's in command. Right now you can see the pitch is just a little shy of 2.5 degrees in level flight. We've also turned on the flight path vector. That is shown right on the horizon at this time. The wings are right on the horizon line, so you can't see the wings of the flight path vector, but you'll see them as we pitch up or pitch down. We've disconnected the auto throttle, we've disconnected the autopilot, and I'm going to pitch the airplane up to just show some of the pitch increments here. So we're going from 2.5 degrees, here we're at 5 degrees. Now you can have a little better view of the flight path vector. There's 7.5 degrees of pitch. We'll continue up to 10 degrees of pitch. 10 degrees is labeled. The airplane symbol is the attitude of the airplane, and the flight path vector is our actual path through the air. They certainly can be different, especially at the slower speeds. Now we'll bring the pitch back down, decreasing through 7.5 degrees, decreasing through 5 degrees. You can see the flight path vector is right on the horizon now. And we're very close to level flight. In fact, if I bring the flight path vector right on the horizon, you'll see that it will be level flight, even though the pitch is saying, or the airplane symbol is saying we're up at 5 degrees of pitch, we're maintaining level flight. Now we'll lower the nose. There's 2.5 degrees pitch up. And now the airplane symbol is at the horizon. And we'll start to pitch down now. We'll go 2.5 degrees pitch down. And we'll increase to 5 degrees pitch down. You'll notice as we continue to pitch down, the airplane symbol and the flight path vector will kind of meet, so now our attitude is the same as our actual path through the air. So around 10 degrees here, we are pointing 10 degrees down, nose down, and we're descending at almost 6,000 feet a minute. We'll bring the nose back up, 2.5 degrees. There's level flight again. There's 2.5 degrees pitch up. And you can see in this case we are climbing. Again, our aircraft attitude right now is the same as the flight path vector, so our actual path through the air is the same as the attitude of the airplane right now. But you'll see as we start to slow down, they'll start to diverge. The pitch will continue higher and our actual path through the air will be different than what the attitude of the airplane is as we slow down. We'll go back to 10,000 feet here, and we'll level off at 10,000 feet. Again, blue represents blue sky, brown represents brown earth, the horizon line is white, our pitch increments are 2.5 degrees, and every 10 degrees you have a mark for the pitch. In between that, you would have to figure out what your pitch is. And right now it's 2.5 degrees, but our actual flight path is pretty much level flight. And that's what the flight path vector is showing. The flight path vector, of course, is that little round symbol with the wings extending out from it. The black symbol, the big black airplane, is the airplane attitude. Here we are at 10,000 feet. Again, just about 2.5 degrees of pitch, and we're maintaining, lower the nose a little bit to maintain 10,000 feet. These flight simulators tend to be a little more sensitive than the actual airplane. Now we're going to bank into a 10-degree bank to the left. And you notice that as we continue the bank, right now we're showing about 18 degrees bank angle. And we're turning left. The bank pointer will point to the right. And again, it's pointing the direction we need to go to level off. And you can see in this case we've continued the turn to 45 degrees of bank. Remember, each bank increment is 10, 20, 30, and we're at the 45 degree mark. That 45 degree mark is considered what's called a steep turn in aviation training terminology. And this is one of the maneuvers that we normally have to demonstrate as part of your scan exercise and to determine you have a good scan and that you could control the airplane, turning left or right 180 degrees. And you can see that at 45 degrees of bank, holding 10,000 feet, the pitch is right around, just right around 5 degrees right now. And I must say, in a flight simulator program like this, it's a little more sensitive than the real simulator or real airplane. The airplane is the most stable of all. The slip skid indicator is the rectangular box under the triangle at the top. And what I'm trying to do now is induce a slip and a skid by walking the rudder. I don't have rudder pedals, I just have a joystick, so what I'm doing is twisting the joystick to move the rudder, since I don't have a rudder pedal setup. But you can see that the box moves to the right and to the left of the triangle as I induce a slip and a skid. The slip, of course, would be if you turn to the left and you add right rudder. The skid would be if you turn to the left and add too much left rudder. Typically we want to keep the ball in the center, or the box in the center in this case. Now what I want to demonstrate is how passing 35 degrees, you can see the indication turns amber. And I'm trying to get the box and the bottom to go full scale, and there it is, to show that it fills in solid. And the only way I could do that is get over to about 90 degrees of bank. These simulators are pretty good, but they're not totally accurate. They're amazingly accurate. And so you can see that this is the way we want the sailboat, pretty much right under the triangle. That's coordinated flight. If we go past 35 degrees, the bank pointer will turn amber, and if we were to vary the into a slip or a skid at full scale, it will go solid as well, either solid white or solid amber if you pass if you're past 35 degrees. Okay, so that completes our discussion of attitude on the PFD. So let's lower the HUD and go flying. Till our next briefing, keep the blue side up. Captain Al, out.